Welcome and thank you for joining me, Miss Trott, once again for Math and Science for Young Children. In each of our sessions, we're going to be reviewing math, science, and early childhood topics. Our goals for this session are to articulate the value of sensory play, gain knowledge of different aspects of measurement concepts in early childhood, apply principles of constructivist learning to mixing solids and liquid ingredients, and distinguishing between convergent and divergent questions and cite advantages or disadvantages for each type. Make sure you download the note sheet to go along with this video and stick around as we learn more about math and science for young children. Sensory activities provide children with another meaningful avenue for learning. Sensory tables or sensory tubs rotated regularly with wondrous sensory materials are worthwhile investments for hours of learning, exploring, and fun. Because children learn best by having hands-on experiences with materials, sensory experiences are vital to young children's learning. Imagine trying to teach a group of 4-year-olds about melting and have them watch an ice cube melt in your hand, or as a grown-up, learning how to use a computer program without actually working on it. These sensory activities and experiences help in cognitive, language, social and emotional, physical, and creative development. A few ways you might have seen sensory activities being used with young children is a fun, play-based, child-directed exploration, which they construct their own knowledge. It's great for calming anxious or frustrated children and improves focus and concentration, and it helps children learn about physical properties and materials. Sensory play is really part of the scientific process. Whether out loud or internal dialogue of the mind, children have developed a question, leading them to investigate. So they might grab, pound, squeeze, smell, and listen to what they have. They're using their senses to collect data, and from that, they attempt to answer their own questions. Whether or not young children are always able to verbally communicate this process, it's still a valid exercise in the scientific inquiry. They investigate their own questions and may use many of the science process skills. Sensory play is also important in developing math skills. These could include measuring, counting, comparing, and estimating. In today's session, we're going to be focusing on measurement. Measurement is a process that produces a quantitative description of an attribute, such as length, circumference, weight, temperature, volume, or number. Measurement for young children starts with comparison: big, little, more, most, tall, short. For young children, the most appropriate focus for measurement activities is one with length and capacity. Length is the measurement of something from end to end, and capacity is the volume, how much a container can hold. With young children, it is often best to use non-standard units of measurement. They are generally not ready for standard units of measurement that adults use because they do not yet fully understand the number system. Non-standard units might include things like Unifix cubes and how many cubes does it take to get to the length of something else. We have 3 big ideas about measurement. The first is that many different attributes can be measured even within a single object. For example, when you're looking at an image of 2 containers, ask the students what different attributes can be measured. We can measure the height, or the width, or maybe the opening, how much they can hold. Many different ways that we can measure that same object. Number 2, all measurement involves a fair comparison. For example, with the containers, a fair comparison would be to measure the same attribute of both containers. We can't measure the height of one and the width of another. We need to measure the same attribute in order for it to be fair. Big idea number 3 is quantifying a measurement helps us describe and compare more precisely. We can use numbers to make comparisons more precisely. For example, we can find out about the big container is not only bigger than the smaller one, but we can precisely find out how much it holds. The big container might hold 2 cups more than the smaller one. Measuring can tell us how much more, or how much less. Our science focus today is solids and liquids. Children enjoy sensory exploration as they mix substances together to find out what happens. The exemplar activity for this session focuses on physical science of solids and liquids. Children mix common ingredients together and observe the interesting and exciting results. In the process of experimenting, they encounter dissolving, changes in texture and consistency, and color mixing. As they create their mixtures, they explore cause and effect, test their predictions, and communicate their results. They use scientific tools and engage multiple senses to help them make discoveries. The underlying science concepts in this exemplar activity are that a mixture is a substance in which two or more substances are combined. Combining different substances together can produce a new substance with different properties like color, texture, or consistency. And substances can be grouped according to their physical properties into solids, liquids, and gases. Make sure that you review all of the engage, explore, and reflect activities as they are listed out in your exemplar guide. After you've completed the activities, make sure that you ask questions such as what kind of mixtures did you make and what other kind of ingredients would you like to use in making other mixtures. Also be sure to do at least one of the ideas for further exploration so you can continue to learn about mixtures. It's always good to have background information on how things work to build up your confidence and make teaching children go smoother. So we're going to take a look at the background information on solids, liquids, and gases. There are three main physical states of matter. Solids have a definite shape, they do not flow, and they are virtually impossible to compress. Their particles are strongly bonded together. Liquids have no definite shape, can flow to take the shape of the bottom of a container, and are very difficult to compress, virtually incompressible. Their particles are weakly bonded to each other and can break their bonds easily. Gases have no fixed shape, they spread or diffuse to completely fill a container, and they are easily compressed. Their particles are free, having no bonds between them. They have much more energy than those of a solid or liquid and fly around bouncing off each other and the walls of their container. Questions make up a large part of our conversations at school and at home with our families and our friends. Questions can be divergent or convergent. Divergent questions do not have a right answer, but provide an opportunity for creativity, guessing, and experimenting. Divergent questions stretch children's thinking. Some examples might be, what do you think? What might happen if? How can you make this object roll? Convergent questions, on the other hand, ask for specific information, such as, how many legs does a spider have? While these questions provide us with feedback on what children recall, when used too often, convergent questions can limit a child's thinking and willingness to guess and experiment. Asking divergent questions or open-ended questions is a wonderful way for many children to respond without hesitation. Most everyone has an opinion when they are asked, what do you like about something? Or sometimes we need to ask convergent questions that require specific answers. Frequently, children's responses are incorrect. Wrong answers should be acknowledged to support the child in his or her effort to respond, and restating the question may help redirect the child's thinking. All answers, correct and incorrect, are an opportunity for adults to evaluate children's understanding and experience with a particular topic or activity. Finding out why a question was answered in a certain way may be more important than the response being right or wrong. Encouraging children to explain their reasoning in cases of both right and wrong answers can provide important insight into their thinking and help identify misconceptions they may have, as well as help them improve their oral expression and ability to communicate. That wraps us up for today's episode. Thank you for joining me for learning all about math and young children. If you have any questions, please feel free to reach out to me or your instructor. We are here to help. Have a great week. See you next time.